Welcome back, everyone. So in this video, what we're going to do is we're going to just spend a little bit of time talking about one of the most important concepts in all of science, not just physics, and that is the conservation of energy. Right? So what does that say? What does the law of conservation of energy say? Well, basically, it says that unless there is some outside force doing work on a system, the total energy in that system will remain the same. All right, so what's that mean? Well, if there's friction involved, that can do work on a system, that can change a system's energy, right? Friction can act as an outside force. If you are dealing with, say, a motor, right? Let's say you have a car going uphill, right? If that car's staying at a constant speed while going uphill, that motor is doing work on the car. It's allowing its kinetic energy to remain the same while increasing its gravitational potential energy, which means that the total energy does not remain the same, right? It goes into what's called the work energy theorem, which says that work is a change in energy. So the only way to change a system's energy is to do work on it, right? So when we talk about the conservation of energy, we're saying that there is no outside force acting on a system. Okay? Now, when dealing with conservation of energy, it's important to remember the following. The total energy of a system for what we're dealing with is the total mechanical energy, right? We ignore thermal energy, we ignore electric energy or nuclear energy or anything like that. We just specifically deal with mechanical energy. So that's your potential energies and your kinetic energies. All right. So we'll say that the total energy in a system is equal to the elastic potential energy. Is there a spring involved? If so, they'll have a term for that. Gravitational potential energy and kinetic energy. That kinetic energy can be both your translational kinetic energy and or your rotational kinetic energy. All right, so let's take a quick example as to what that means. All right, very common for a problem like this to be presented as a roller coaster or some kind of ramp or something along those lines. So let's take a look at this point here. We'll call this point A. Okay, I'm going to call this point B. I'll show you in a second point C and point D. All right. So here we go. Now, I'm not going to label it, but you know there'd be some heights here, so on and so forth. Now, for each point, you have to take a look at what that types of energy that system is, or that at that point. So let's say, just to start, that at point A, the cart is at rest. Okay, well, there's no spring, so there's no elastic potential energy, and it's at rest, so there's no kinetic energy. So if this is at rest here, since it's above some height, 0, 0, it's only got gravitational potential energy. You've got to read the question, though. Maybe it's rolling here. If that's the case, then you've got kinetic and gravitational at this point. All right, but let's go back to us saying it starts at rest up here, so it's only got gravitational potential energy. Well, the total energy of the system is this gravitational potential energy at point A. At no other point will the total energy be any greater or less. That's the conservation of energy. All right, so it starts then rolling at B. Okay, well, that total energy is then the kinetic energy at point B, how fast it's moving, 1/2 mv squared, plus mgh, whatever this height is here. Okay, as it goes all the way down, right, we'll say C is at ground level, so there's no height. There's no spring, so that's 0. There's no height, so your gravitational potential energy is 0, so it's only got kinetic. Okay, then it comes up here, right? We're at the top of a bump again, but that bump is not as high. So we can't say that it's just gravitational potential energy because it's going to come down and roll here. So we'll say it's got some gravitational potential and kinetic, right? So you've got to be able to look at the system and see, okay, what kinds of energy might it have there? How is that related to the total energy? What's the best way I can find the total energy of the system? Well, if this value here, if the total energy here is just the gravitational potential energy, you can use that to help base calculations off the rest of it. Okay? The biggest thing I can tell you is for any problem, check to see what kinds of energies the object or objects might have at any given point. If it's got a speed, it's got kinetic. If it's above some height, it's got gravitational potential. If any spring at all is even a little bit compressed, it's got elastic potential energy. Right? So you've got to look at each individual spot. Usually a question will be labeled point A, point B, so on and so forth. And you've got to be able to look and see, okay, what can I deal with here, 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 here? How can I use it to solve for whatever it is they're asking? Okay, so that's pretty much all I got for conservation of energy. Just understand that unless that work is being done, unless you need to use that work energy theorem, where work is a change in energy, your energy is going to be conserved. Okay, so I hope that was helpful. I'll see you next time.